Thank you. So my name is Chennault. I'm a hydrogeologist and surface water engineer with Associated Earth Sciences. I first started working in the Nooksack Basin in the late 1990s as an intern with the U.S. Geological Survey. One of my first tasks was to start compiling the baseline assessment data for the initial WIRA-1 work that was being done. Later, I moved into the stream gauging unit at the USGS, and so I spent a lot of time running around Skagit, Snohomish, and Whatcom counties, measuring stream flow and compiling stream flow records. At the same time, I was a graduate student under Bob Mitchell at Western in the geology program, and my research there involved climate change impacted stream flows in the North Cascades. So I guess because of my background, I get asked quite a bit in our line of work, kind of about in-stream flow rules and what they mean and where they came from. And so I thought this conference was a good opportunity to help inform that discussion with some of the things that I know or I think I know. So kind of the first questions are kind of why and how in-stream flow rules are established. The why may seem pretty straightforward, but in a nutshell, the purpose of an in-stream flow rule is to help preserve in-stream resources by limiting the availability of future out-of-stream water use. And then how those are established, we'll be going through that today, but the meat of how the in-stream flow rule was established in the Nooksack is this document, which is the Nooksack In-Stream Resources Protection Program. The work was done by Ecology in the mid-1980s. The date on the document is November 1985. And the rule, where the flows are in the administrative code, is in Chapter 173.501 of the WAC, which was adopted in 1988. So I'd like to talk a little bit about what do historic, current, and future stream flows in the Nooksack look like in comparison to the rule, and kind of conclude by a little bit of kind of what it means. As with most in-stream flow rules, the Nooksack the in-stream flow rule was first set out with the habitat study. So in the mid-1980s, these studies were pretty basic. Most of the streams and reaches in the Nooksack Basin included a tow width field survey for the habitat portion. But there was a few reaches, the Nooksack Forks, and a few creeks that used the more advanced in-stream flow incremental methodology to establish what flows might be ideal for fish habitat. The second piece is essentially the timing of fish. So what flows are ideal for fish, and then when are the fish in the streams, various reaches, and what life stages are they doing those things. And the third piece, the piece that I'm most familiar with, is the stream hydrology piece. So in the Nooksack rule, the stream hydrology focused on the 50% exceedance flow hydrograph for all of the streams and reaches in the rule. So a 50% flow exceedance is essentially the median flow of the stream. So 50% of those days in the period of record that they analyzed were above a certain flow, and 50% of those days were below a certain flow. And it was typical for the time period to focus on the 50% exceedance. Flows that were established in the 70s typically didn't have a habitat component and were generally set somewhere between the 90% exceedance and the 50% exceedance flow. So the 90% exceedance is a pretty low flow. It's exceeded statistically 9 out of 10 years in the period of record. In the 80s, as I mentioned, there was typically a habitat component, and flows that they focused on were the 50% exceedances. And today, flows are typically set using more advanced habitat models, and then the 10% exceedance flow. So the flow that is statistically only exceeded 1 out of every 10 years is become kind of the norm for in-stream flows. So to illustrate that point, I'd like to go through the Nooksack River at Ferndale as as kind of an example of how the rule was set. So this is a stream flow hydrograph. They all go from January through December across the bottom axis. And this is a logarithmic scale of stream flow discharge in CFS. For the Nooksack River at Ferndale, they used USGS stream flow data that you may not be able to see is October 1966 through September 1979. So 12 years of data for the Nooksack River at Ferndale. And these are the flows that are in the rule. As you can see, so we're in September, late September. The in-stream flow in the rule is 1,700 CFS. And graphically, those flows are represented by this dark black line. Difficult to see, I know, but it corresponds really well with this 50% occurrence flow. So if you're like me, you know, this hydrograph, which is in this 1985 document, is kind of difficult to decipher. So I made my own. And so this is Nooksack River at Ferndale, 1966 to 1979. The 50% exceedance flow is this dark green line. As you can see, the in-stream flow that's in the rule follows pretty closely to that 50% exceedance flow. So one of the other questions that I get asked pretty frequently is, these flows were, from the 60s and 70s. What do flows look like today in comparison with the rule? So I added that data to the chart, the same statistics. And so this is from 1980 to 2016. So essentially all the flows in the Nooksack River at Ferndale after the data that was used in the rule. And this is dark green line again. As you can see, the flow, particularly in that low flow period, the 50% exceedance flows are well below the established in-stream flow. And it's basically the in-stream flow falls kind of between the 10% exceedance and the 50% exceedance. So as we, have heard lots of speakers talk about, climate is changing, flows are getting lower, particularly in the low flow period, and you can see that in the data, even from the 60s and 70s to today. So taking that further, we can look at an example. This is the Nooksack River in 2006. So the blue line is actual stream flow recorded in the Nooksack River by the USGS in 2006. One way to assess the how the flows that were measured in the river relate to the in-stream flow is just a simple accounting. How many days were below the in-stream flow in that year? So for 2006, there was 167 days below the in-stream flow. You can see there's a few here in the late winter, early spring, but most of them fall in that predictable, low flow period. And so 167 days, and if you think about it, when the flows are essentially established based on a 50% exceedance flow, it's not that surprising that, you'd have 167 days that fall below the in-stream flow in a given year. 2006 was pretty average. It may have been, a little drier in the summer than kind of the average year. The median, just for your information, of days below the in-stream flow for the period of record of the Nooksack gauge is 151 days per year is kind of the median year. So as folks like Bob are doing, they're working on climate change models to try to predict stream flows in the future. There's a group down at the University of Washington doing similar things, the Climate Impacts Group. And so they have stream flow data that they're projecting for the Nooksack River at Ferndale that we can use to kind of modify this 2006 measured data into what a year like 2006 might look like with the climate in 2020. So that hydrograph is here in green, and as you can see, your flows are lower and you start to drop below the in-stream flow earlier in the year. And so instead of 167 days, you're up to 180 days below the in-stream flow. In 2040, you're up to 185 days as that shift in the hydrograph continues. And then by 2080, the days below the in-stream flow is up to 192 days. So the same kind of shift that Bob was showing earlier in their work. The flows are actually higher in the peak flows in the winter, and then lower in that late spring and through the summer. So another question I get asked quite a bit when it's related to in-stream flows is kind of its relationship to water use. And I think one of the reasons it's hard to wrap our brains around kind of comparing water use to stream flow is that the units are different. You know, stream flow is measured in cubic feet per second. When we're talking about water use, we're typically talking about a pumping rate in gallons per minute, or a daily use in gallons per day, or million gallons per day, or acre feet per year. It's a challenge to kind of wrap your head around what does that mean in CFS. I remember Catherine Mitchell talked yesterday about Alcoa using 1 million gallons per day of water, which sounds like a lot of water, and it is a lot of water, but it's equal to about 1.5 CFS. So I thought it would be useful and add up all the water use in the Nooksack Basin, both surface water and groundwater use, you know, put it all together and convert it to CFS and kind of see how it compares with in-stream flow. So, you know, irrigation is a large user, particularly during the irrigation season. You know, you've got these other uses, and you lump it all together and you add it up simply, and you come up with about 216 CFS of water use during the irrigation season, and 65 CFS of water use in the non-irrigation season. And I looked today, you know, I mentioned the in-stream flow in the Nooksack right now is in the code is 1,700 CFS. I looked this morning, and the flow is currently about 960 CFS. So in terms of the hydrograph, we use our same 2006 example in Ferndale, and we have 167 days that were below the in-stream flow. If you take all the water use in the Nooksack Basin, you stick it in the river, and you still have 158 days that fell below in-stream flow. So if you magically shut off all the water use, you know, stream flow would still be not meeting in-stream flows for a good chunk of the year. So as I conclude, I just wanted to bring up a few points about the in-stream flow rule, you know, what it is and what it isn't. You know, the in-stream flow rule is a water right with a priority date. So just like any other water right with a priority date, it can't be impaired by any junior water rights. So that means the in-stream flow applies to future water rights. So water rights applications or allocations after June 9th, 1988. And based on the Hearst decision, we know now that that's being interpreted to also apply to what was previously permit exempt water use, so individual single-family domestic wells, for example. So an in-stream flow is not require anyone to put any water into the stream. If flow is below the in-stream flow rule, you know, nobody's required to put water back into the stream. That's not what it is. If flow is below the in-stream flow, that's not necessarily a violation of the rule. And then finally, you know, utilizing a water right that was issued prior to the in-stream flow rule, kind of by definition, cannot cause a violation of the rule. So with that, if I have time, I will answer questions.
Thanks, Jay. When you are accounting for all of the out-of-stream water use, is that, how are you measuring that? Is that paper water rights? What does that count? So,
yeah, I glossed over the sources, but the irrigation water rights were pulled out of a document that RH2 sponsor put together in 2016, and that was based on crops and crop efficiencies and irrigation efficiencies. And it's detailed in their report, but that was their best estimate of actual irrigation water use. The rest of these were out of the lower Nooksack water budget document done in 2012, which similarly went through you know, an accounting of their best guess of actual water use. The RH2 document does go through the kind of the paper water rights exercise, but this value was derived based on their best estimate of actual irrigation water use. And it's in acre feet per year, and so I compressed it into 180 or 120 days irrigation season.
This has been puzzling to me for a while. So you're saying it's expected to not meet 50% of the time this rule?
Yes.
So that's the expectation. So I'm not clear how that applies to binding the future water rights you said at the end.
Yes, so the way the rule is applied is when the in-stream flow isn't met, it means there's not water available for any out-of-stream water use. So that's how it limits future water use allocations.
But you'll always expect that. So I'm not getting it. Sorry. You said that's always going to occur. It will always, 50% of the time, not meet the flow requirements. Am I misunderstanding this?
No, you're understanding it correctly. So essentially, post in-stream flow rule, there is not water available for any out-of-stream use on a year-round uninterruptible basis, is how it works. That's the practical application of the rule.
So even though we pull the water all the time,
The water that's being pulled all the time is water rights that are prior to the adoption of the in-stream flow rule. So those are seniors, so those are allowed. So most of the water rights that are being utilized for municipal irrigation, et cetera, predate the in-stream flow rule. So the in-stream flow rule only applies to future water rights after June 9th, 1988.
okay, thank you.
Thank you, Jay.